Okay, welcome to the third in this series of videos on how to solve projectile problems. This one's getting a bit more complicated. We have now an object projected off the top of a 200-metre cliff. It's projected again at 100 metres per second at an angle of 6 degrees to the horizontal, and it lands at velocity v. The range, horizontal range, is r. And we've got to work out fundamentally what this R is and what this V is. So what's R and what's V are our two questions. Now to answer these questions, we first have to work out what the time of flight is. It's pretty typical in these problems that you work out the time of flight. So I'll do that first. Time of flight. And we're going to look at the vertical motion only to work out the time of flight. Two, we want to find out. Now, S this time is minus 200 metres. So vertically, starts here, ends up vertically at this point here. Horizontally, it's changed position, but vertically, it's straight under where it started, and it's actually fallen 200 metres. And so the displacement is minus 200. Upwards is positive. Downwards is negative, so minus 200, and we have the acceleration is minus 9.8 metres per second squared, and we have the initial velocity. This time again, 100 sine 60, which is 86.7 metres per second. And that's positive because it's going upwards. And we're going to use S equals ut plus half a t squared. Again, we're just looking at the vertical. S is minus 200 equals U, 86.7 T. Half A is half of minus 9.8, so that's minus 4.9 T squared. And we need to get this in the form of AX squared plus BX plus C equals 0. So it becomes 4.9 T squared, putting this over the other side. Put this over the other side, minus 86.7 T. Minus 200 equals 0. Now, a lot of people don't do this problem this way. They work it out in sections. How long does it take to reach the maximum height? How long does it take to reach the same horizontal level, and then, or the same vertical level, sorry. Then how long does it take them it fall the extra way? That's 3 steps. And I always find that's 3 spots you can make mistakes. Part of that is that they're a bit scared of using the quadratic formula. So we're not going to be scared of using that. Formula is ax squared plus bx plus c equals 0. Therefore x is equal to minus b. This is the coefficient of x, plus or minus the square root of b squared. Minus 4a, it's a coefficient of x squared, c, that's the distance constant, over 2a, minus b plus or minus the square root of b squared minus 4ac over 2a. You've simply got to learn that. So we're going to substitute that in using this equation here. So there's our equation, a quadratic equation. We're going to therefore say t equals minus b, so it's minus 86.7, so that's 86.7. Plus or minus the square root, I'll have to go down here, of b squared, so it's 86 minus 86.7 squared, minus 4 times a is 4.9, times c is minus 200. All over 2 times 4.9, times 4.9, all over 2a. This is tidied up a bit, equals 86.7 plus or minus square root of 86.7 squared, minus times minus is going to give you a plus. Minus times minus here is going to be plus 4 times 4.9 times 200, all over 2 times 4.9, 9.8. Now I've already done that, so I thought this should be a bit more time consuming, so I've already done it. That comes out as 18.8 seconds. 18.8 seconds. Therefore, t, time of flight, put it left there if you wish, Now, we're going to look at the horizontal range. That's what we're trying to find. Now, it shouldn't be any surprise if it's horizontal range, we're looking at just the horizontal motion. So horizontal motion. And we're looking at S, that's what we're trying to find, that's R. R equals S. We're looking at the fact that the acceleration is 0, there is no force acting horizontally. We ignore air resistance. So A is 0. T, it's going to be the same time of the vertical motion, so 18.8 seconds. And that's about it. So S equals ut plus half at squared. That goes because A is 0. So S equals u. U, here we go. U is horizontally 50. It's 100 cos 60, which is 50 meters per second. So 50 times 18.8, and that comes out as 939.0 meters. So there's our horizontal range. Now our velocity of impact, we want this velocity, V. We have a horizontal component, which is 50, doesn't change, and we have a vertical component, which is, we're going to say V vertical. This is your final velocity. This is our V. And we're going to add those by vectors, ultimately. So, our vertical component, u plus at, we can use. U was 86.7. A is minus 9.8 times t, which is 18.8. And we get that velocity, vertical velocity of impact is 109.6 meters per second. Now we're going to solve that by Pythagoras. There's our hypotenuse, there's our two sides. So our V is going to be the square, doing a couple of steps here in one. V squared equals VV squared plus VH squared. That's horizontal. So it's actually 109.6 squared plus 50 squared, square root of that, and that comes out as actually that's what's comes out at 109.6. 9.6. I'm just going to, because I'm not going to redo this video, I've just made a little bit of mistake here reading my stuff. This is not that, I should have realised because that should be minus. There you go, if you make a mistake, go back and fix it up. So this actually comes out as minus 97.5 meters per second. So this is going to be 97.5 squared plus 50 squared. Okay, now this is better. Because I should have said, you know, the negative answer because it's going down, and down is negative, so that's right. Now I've got this is actually 97.5, this is 50, and we're solving that. That comes out as 109.6 meters per second. And then we need this angle theta. Tan of theta is 97.5 over 50, opposite over adjacent. So theta is tan minus 1, 97.5 over 50, and that comes out as 65.5 degrees. And that fundamentally solves a problem. Often you'll get asked what's the maximum height, and a few things like that, but fundamentally that's the style of problem you get. Shouldn't be afraid of using the quadratic formula, a bit of practice, and you'll be fine with it. Minus b plus or minus square root of b squared minus 4ac all over 2a. Now, to get that into your long-term memory, you write it out half a dozen times, and then a few days later write it out half a dozen times again, and then a few days later write it out half a dozen times again. You'll have that in your long-term memory, and then you'll be able to use it. So, but you absolutely, to solve this problem this way, you certainly need to know that quadratic formula and then have lots of practice at using it. Thanks, hope that makes a bit of sense for you.